All right, hello everybody, Noah here with Learn Meta-Analysis, and we are continuing our 3-level meta-analysis today. And so far, in previous videos, we have calculated effect sizes, we've run our overall meta-analysis, we've looked at heterogeneity and variance, we looked at outliers and influence, and we have run a categorical moderator analysis. Now we are going to create some plots. Okay, so first and foremost, I want to mention that there's a lot of different ways you can create plots. Like you can create your forest plot using like the normal forest plot code from Metafor. I'm not going to show you that method today. I think it's pretty reasonably well documented how to do that. Instead, I'm going to show you some codes that are slightly adapted from another paper by Fernandez Castilla et al. In 2020. And the reason is because it's a little bit different, and I just think it's kind of cool, and I want to share it with you guys. So we're going to run through this code. This is probably going to be a pretty quick video because frankly, I don't understand a lot of the code here. A lot of it is like graphics related code, and I'm not very good at that. So the one thing that I want to point out before we start is we need to format our data in a different way. So I have an example data set for you that is based on our data set earlier, and I made some adjustments to it. So this is well explained in my book, What Things We Need. I put a link to the free open book down in the description. And again, you don't have to download it or anything. You just read it on a web page. So that's there. I'm not going to go through all that right now, but basically, long story short, this file is called data for plots in the example. So we're going to load up a bunch of different packages, and we're also just going to go ahead and load this data. We're going to do that first. All right, so you can see that's done. Next, we are going to run this whole big, huge hunk of code. And yes, can you see now why I don't want to explain every line of it? All the way through here, and we hit run. All right, so over here on the right, this is what we get as a result. This is our forest plot, but this is a little bit different than the forest plot you might expect to see coming out of Metafor, right? It looks quite different than that. So here is how it is different. So number one, all of the code that I just used, it's very, very slightly adapted from their paper. So please don't think I wrote this. I did not write this big chunk of code. This is all pretty much directly from their paper, and I just made some very slight adaptations to our data. So on the left side, you can see the study author names. On the right side, you can see J equals is the number of comparisons from each one. And then what we can see is some more information here in the middle. So first and foremost, our pooled effect size is negative 0.38, which we knew from running our overall analysis. We can see that we have a pretty big range of effect sizes, right? Since this one is all the way down here, like somewhere around -6. So let me see what my notes say about interpreting these particular bars and things. So to quickly explain some major points, the black boxes are the average effect size from the comparisons within each study. The black lines are the study precision, and the gray lines are the median precision of one effect size from each study. The size of the box is relative to its weight in the overall analysis. So I know I went through that really quickly, but I would suggest just looking at their paper if you really like this type of forest plot, and personally I do. I think this is really informative, and I think it's honestly, it's kind of, I just feel it's elegant. I can't really explain why I feel that way. I just feel like all the information that I want is there, and I like it. And so because I like it is why I chose to show it to you guys and give you guys the code to create it. I've used this code in at least one of my own papers, and it's also built into the simple meta-analysis software just because I think this gives us a really nice looking forest plot here. All right, so next we're going to run a caterpillar plot with all effect sizes. So we're going to highlight this next big chunk of code, and we're going to hit run. And so what this does is it looks a little bit like a caterpillar, right? But it shows us our overall effect size here as this line, and then we can see each comparison within that, and they are ordered from smallest to largest. Next, we can do another caterpillar plot, and this time we're going to run it by study. Okay, so here you can see obviously we have a lot fewer data points because we have much fewer studies than we do effect sizes, and we can see what this looks like. So what are caterpillar plots used for? Honestly, really just describing our data is how I think about them. I think about them as just contextual information. So now let's move on and think about publication bias. Okay, so with publication bias, we cannot use the standard tests that we would use in a conventional meta-analysis. They have inflated type 1 error rates. There's a wonderful paper that talks about that. And so instead, what we are going to do is we are going to just create funnel plots, and we are going to look at the funnel plots for any obvious asymmetry. So we're going to run this big, huge hunk of code. And again, this is still coming from that same paper. So we're going to highlight this and run it. This is a funnel plot here, and you can see it is pretty asymmetrical, right? So we can see it's pretty asymmetrical. There's lots of stuff over here on the right, not nearly as much over here on the left. And then we're gonna now do a funnel plot by study, again using this big, huge hunk of code. Oh, it brings us to the end of our code. Wonderful. Okay, and here's a second one where we're looking at it by study, and we can see it really is pretty asymmetrical here. So what does this tell us? This means that it doesn't necessarily mean we have publication bias per se. It means that we are missing some representation, right? So we don't know the cause of this missingness, but we can definitely say that there seems to be some things missing here. And so what does that mean for our analysis? Well, kind of depends. It kind of depends on your interpretation of what this means for your particular study. I don't really want to dive too much into that. So the one thing I will say is these are, again, a little bit different than what you could create using metafor, but you can still create funnel plots with metafor, with multi-level models, and you can still create forest plots with multi-level models in metafor. So like I said, those are pretty well documented, how to create a forest plot with metafor and how to create a funnel plot with metafor. So I want to show you guys this other one just because I think it makes pretty nice looking plots that are specifically made for dependent data. And I have just really enjoyed them. When I found out about this, I was like, you know, this is something that I'm going to use in my own work, and that's why I wanted to share it with you guys today. So like I said, the biggest surprise here to me when I was learning about 3-level stuff was that the actual publication bias tests, there really aren't very many that you can use, okay? So there is a variant of Egger's regression that you can use in some circumstances, but for myself personally, I've been using the funnel plots and looking at funnel plots because there just doesn't seem to be good methods yet. So perhaps if you are interested in making advancements in meta-analysis, you know, maybe that would be an interesting area to look into, looking at publication bias testing for dependent data models. So that could be an interesting thing for people who really like stats. So, okay, I'm gonna stop rambling here. Long story short, you have to structure your data a little bit differently to be able to use this code from their paper. However, it will give you some absolutely beautiful plots that you might find helpful in your meta-analysis. And to be honest, this is our last video on 3-level meta-analysis. I hope this has been helpful for you guys. Again, there's links to all the resources to recreate these analyses on your own in the description to the video. So if this video series has been helpful to you, please remember to like and subscribe. It helps support the channel. Thank you.